This is Malini and you are watching Edification. This video is about a shocking element. Yes, it is about the current. By the end of this video, you will have a clear understanding about current. Every action has an equal and opposite reaction. Here, applied voltage is the action and current is the reaction to the applied voltage. Consider an isolated copper wire, just a wire. It seems dead or inactive from outside. But if you look into it in microscopic level, it's very much active. Remember the 29th electron of copper, the free electron? There will be a large number of free electrons inside the copper wire and will be moving randomly in all directions such that the net flow at any one direction is zero. Now these free electrons, they will be roaming here and there and they will not do any useful work. All these free electrons must move in a specific direction to perform some useful work. This is done by simply applying voltage across the wire to force the electrons to move towards the positive terminal of the battery. Now, why should they move towards the positive terminal of the battery? Because obviously the electrons are negatively charged. So, as soon as you connect this wire to the battery terminals, the negative electrons will be attracted towards the positive terminal of the battery. As the electrons pass through the wire, the negative terminal of the battery acts as a supply of additional electrons to keep the process moving. And the free electrons in the copper wire will reach the positive terminal and get neutralized there. Due to the battery action, the electrons will be deposited on the negative terminal of the battery. So let's make the simple electric circuit consisting of a light bulb connected to a battery using a copper wire. As soon as the connection is made, the free electrons of negative charge drift towards the positive terminal. The flow of electrons through the bulb heats up the filament of the bulb to the point that it glows red hot and emits the desired light. In this manner, the flow of charge or electric current is established by the voltage. Consider an imaginary plane in the copper wire. If a 1 coulomb of charge, that is 6.242 into 10 power 18 electrons, passes through the imaginary plane in 1 second, the flow of charge or current is said to be 1 ampere. I repeat, if 1 coulomb of charge passes through the imaginary plane in 1 second, the current is said to be 1 ampere. The current in amperes can be determined using the equation I is equal to Q by T, where I is the current in amperes, Q is the charge in coulomb, and T is the time in seconds. The unit of measurement of current is ampere and it was chosen to honor the efforts of André Ampère. André Ampère is a French physicist and he has done great works based on electricity in motion. Do you know why we are using the notation I to indicate current? That is also because of this André Ampère. Since he is a French physicist, in French the current is called intensity. That's why we are using the notation I for current. Please press the subscribe button and hit the bell icon. See you in the next video. Thank you.